Today's reading for ELA is a ReadWorks article, and it is entitled Chemical Weathering of Rocks. Now, this week we've already read about physical weathering, and I want to remind you that physical weathering is the physical breaking up of rock into smaller pieces. And that can be done from the sun as it heats and expands rocks, and then as those heated rocks cool, they contract, which causes the outer layers of the rock to begin to kind of fall off. It can be done by water getting trapped in some pores within the rock, and as that water freezes, the water expands, breaking the rock. And it can also be done, physical weathering can also be caused by animals and plants that might burrow into certain areas, loosening up rock and causing that rock to be eroded away. And then we also know that plants can grow on rocks. If you look at rocks out, in the mountains, you'll see that sometimes trees are growing out of them, or larger plants even, and the roots of those trees can physically break apart the rock. But we're going to learn that plants can also cause chemical weathering. Some plants can. So what I want you to think about today is kind of how chemical weathering differs from physical weathering, and what exactly is chemical weathering. So the process of weathering breaks rocks into smaller pieces. Some of these tiny pieces combine with once living material to form topsoil. Other small pieces of rock collect as sediments. One basic type of weathering is chemical weathering. So this top paragraph is really, we already read that paragraph yesterday, so we haven't learned anything new, but I think we're going to start to learn more about chemical weathering in this next paragraph. Chemical weathering breaks down rocks by changing the minerals that they contain. So it's an actual change in minerals, whereas physical weathering is just breaking into smaller pieces of the same mineral. So rain is a powerful chemical weathering force. As rain falls, it mixes with the gas carbon dioxide in the air. The result is acid rain. So rain mixes with carbon dioxide and causes acid rain. Acid rain is strong enough to dissolve some minerals and rocks, and it's this acid rain that dissolves minerals and rocks. Once dissolved, the minerals easily wash away, weakening the rock. Acid rain very slowly carves some rocks into different shapes. It gradually erases the lettering on old gravestones and blurs the faces of stone statues. I'm going to just identify those by number. So it can carve rock. It can carve rock into different shapes. It can erase lettering on gravestones, and it can blur the faces of stone statues. It eats away at the outside of ancient and even modern buildings. So it can eat away modern buildings and ancient buildings. Where rain seeps into the ground, carbonic acid causes weathering of buried rocks as well. Over long periods of time, this often unobserved weathering creates caves deep underground. And I don't know if you guys have ever been to an underground cavern or walked through some limestone caves, but they're really, really beautiful. Another gas in the air, oxygen, causes chemical weathering in rocks. With a little help from water, oxygen reacts with iron-containing minerals. So we have water and oxygen reacting with iron-containing minerals. So the first real form of weathering we had up here was kind of acid rain, and then these are what acid rain kind of causes. And then the second one we're going to have is the oxygen in water is reacting with iron-containing minerals. The reaction changes the minerals, making the rocks brittle and crumbly, and turning them a rusty red color. Some plants release rock weathering substances, so we also get chemical weathering from plants. Take a peek under a patch of moss growing on a rock, and you'll see little pits in the rock's surface. Acid from the moss plant caused the damage. As a result of all weathering, rocks are broken down into smaller pieces and ultimately into sediments. So it's just a matter of how the rocks are broken down. Now, the main key that we need to remember here is that chemical weathering changes the minerals rocks contain. I'm going to write that down here. And I wrote, chemical weathering changes minerals contained in rocks. Acid rain is one form. So acid rain is water mixed with carbon dioxide. And this dissolves minerals in rocks. So acid rain is water mixed with carbon dioxide that dissolves minerals in rocks. And the way that the result of this can be carving rocks. And then we have erasing letters on gravestones. Oh, S, not D. 3 was blurring statues, or eroding statues, rather. We'll just put blurring statues. And then it can eat away the outside of buildings, very similar to how it works on the statues and the gravestones. But our big one we want to remember is it can carve out caves. So it can create caves underground. Caves, caverns. Oops. So our chemical weathering in our first form was acid rain. Our second form is going to be the oxygen that is contained in the air, and when water mixes with it, it can react with iron containing minerals. So I'm going to put that on the back so I have room. Containing minerals, and this creates rust. So this creates red rust. Kind of like eating away at the rock. And then our third way, I'll remind you, is that plants can release substances too. So we have acid from mosses. So our third way of chemical weathering. So plants can release substances, and I'm going to put right here that can be acid, that weathers rocks. Okay. And so we have read and identified what chemical weathering is, and we identified also 3 main ways that chemical weathering occurs, and how chemical weathering also can break up the minerals in rocks and make those rocks more vulnerable to being weathered over time.